In this video lecture, I will explain null NFA and also how to find the null closure of a given state. So what is null NFA? We also call it null non-deterministic finite automata. So like DFA and NFA, null NFA also defined by 5 tuples. So null NFA also will have 5 tuples: Q, sigma, Q naught, F and delta. So Q will be same as NFA and DFA, set of finite set of states, and sigma is a finite set of input symbols. Q naught is the start state, F is the final state, and delta is the transition function, which will be mapping between Q into sigma union null to subset of 2 to the power Q. So we will see why it is so. So for example, if I say this is a null NFA, I have a state Q naught, and then Q1 and Q2 is the final state, okay, and Q naught is the start state. And for input A, machine remains in the same state. If I give epsilon, machine is moving from Q naught to Q1. Again epsilon, machine is moving from Q1 to Q2. For input B, on Q1 it remains in the same state. For input C, it remains in the same state. So this is transition graph for null NFA, okay. And here you can see why it is null NFA, because it is possible for a machine to make a transition from one state to another state without giving any input. So null transitions are also involved, so that's why we call it null NFA. So now if I say delta of Q naught A, it is Q naught. Delta of Q naught B, it is phi. Delta of Q naught C, it is phi again. And here you can see A, B, C, there are 3 inputs. So sigma is equal to A, B and C. And delta of Q naught null epsilon, it is Q1. Okay. So you can see in this transition function, the first tuple of delta is going to come from the set capital Q. Here capital Q is nothing but Q naught, Q1 and Q2, and sigma is nothing but A, B and C, and Q naught is the start state here also, and Q2 is the final state. Okay, so the first tuple is going to come from the state capital Q into the second tuple. It can be input alphabet, I mean A, B or C, or it can be even epsilon. So always remember, this epsilon does not belong to input alphabet. Okay, so it will be sigma union epsilon, because even second parameter of the transition function can be epsilon or no input, or we can say null also. And this I am getting Q naught, here Q1 and even phi. So it will be a subset of subset of Q, or 2 to the power Q, we will say. So that's how we have written the transition function for null NFA. Now we'll see how to find the null closure of any state. So what is null closure? Null closure of a state Q, or we also call it null closure, is the set of all states including itself that can be reached from Q by repeatedly making an arbitrary number of null transition. So what is the meaning of that? If I say here we have Q naught dash, Q naught, Q1 and Q2. These are the states, and this is the start state and this is the final state. So if I have to find the null closure of Q naught dash, it will be any null closure of any state will be that state itself, okay, including that state itself, all those states which can be reached from Q using null move. So you can see for Q naught dash is going to come, and then from Q naught dash I can reach to Q naught using null move. So even Q naught is going to come, and then from Q naught there is no null move, there is no null transition. It is for 0 and 1. So we'll stop here. And then same way for Q naught, if I have to find, it will be only Q naught, because any other state cannot be reached from Q naught using null move. And null closure of Q1 also will be only Q1, because any other state cannot be reached from Q1 using null move. So anyway, that state will come. So for Q naught, Q naught also, Q naught will be there, Q1 null closure will be Q1, and for Q2 null closure will be Q2 only, because any other state cannot be reached from Q2 using null move. So this is how we find the null closure of any state. So hope the concept is clear to you. Thank you for watching.